Temperature monitoring can be fundamental when the aim is to avoid dangerous or unwanted events. Videotec's thermal cameras are made to successfully prevent the most insidious hidden threats. Videotec offers thermal cameras for a wide range of applications in the toughest industrial environments, with the ability to quickly and accurately identify potential problems, minimizing the operator's intervention. The upcoming webinar will go over some application fields of Videotec's thermal imaging cameras. Keep watching.
Hello everyone, and welcome to our third digital event. Today we'll be discussing the benefits from our thermal analytics. We'll be showcasing a couple applications within the industrial vertical market. This can include automation, process monitoring, and preventative maintenance. In today's presenters is my colleague Frank Felici. He's located up in Toronto, Canada. Frank is a father, husband, and a proud owner of his dog Jax. Loves everything about Harley-Davidsons, speaks an impressive 3 languages, and enjoys good talks with great company. Frank has over 35 years of experience in the CCTV industry.
Thank you, Ryan. Ryan lives in Plattsburgh, New York. He has a 7-year-old son, Kobe, and 2-year-old son, William. He enjoys playing golf, and when he's not working on his craft, he's spending quality time with his family. He's been with Videotec now for 3 years. Let's discuss the thermal export control process. Thermal cameras are export controlled. When deploying a 9 Hz thermal camera, an end user statement is required to be completed by an officer in charge of the project. When using 30 Hz, a high frequency, all parties, integrator and distributor, must also complete a similar document and wait for approvals before it can be shipped. This is required for all thermal products, regardless of the manufacturer. This current slide is an example of a 9 Hz low-frequency application. This slide deals with helping individuals see what the naked eye cannot. However, helping you see even when there is no light is only a fraction of what thermal imaging is used for. This technology offers benefits ranging from industrial advantages and a reduction of nuisance alarms. The levels created by Johnson's criteria for thermal networking cameras is as follows. First, detection. At least 1.5 pixels are needed for the observer to see what an object is present. Second, recognition. At least 6 pixels are needed for the observer to distinguish an object, for example, a person in front of a fence. And lastly, identification. At least 12 pixels are needed on target for the observer to both distinguish an object and its characteristics, such as a person holding a crowbar. Johnson's criteria was developed under the assumption that visible information was processed by a human observer. If the information is processed by an application algorithm, there will be a specific requirement on the number of pixels needed on the target for reliable operation. Contactless measurement of temperature with thermographic cameras allow for efficient and reliable monitoring. We are able to control temperature critical processes or automated quality control for most industries. The best conditions for measuring temperature are the following. You want to avoid large fluctuation of temperature and humidity for indoor environments, and the camera should be at least 10 meters from the object to minimize measurement errors and have a black opaque target to maximize emissivity. Deploying radiometry for outdoor surveillance systems may vary because of the environment conditions. Radiometry may be affected by transient effects, even if global conditions do not change. Microbolometers may break if the target's too hot. For our first point, it's necessary to configure rules with adequate margin. For example, detecting wood burning can be made robust by taking into account that there's a huge gap between the temperature of the fire versus the temperatures of the forest. Robust rules not only require an adequate threshold, but they must be set on the average value and not the minimum or maximum value of the region of interest, also known as the ROI. The size of the ROI must span the largest area possible in the image to ensure a good quality sample of measurement. For the second point is what a transient effect is in outdoor environments. The probability that undesired light reflects the thermal camera is unnegligible. Similarly, flying objects or animals can lead to false positives. For this reason, Videotec offers our customers a temporal filtering to the measures to filter out false alarms and to make the measurements more accurate. Finally, the manufacturing technology of the sensor has to be considered. Currently, there's two technologies that exist for microbolometers. There's vanadium oxide and amorphous silicone. Vanadium oxide is the older technology and in general leads with superior properties. One of the most important aspects is that the measurable temperature range of the target is wide, and it can measure high temperature without breaking. On the other hand, amorphous silicone is a more recent and less costly technology. In general, it's cheaper due to its CMOS fabrication process. It has limitations with high temperature measurement. Radiometry amorphous silicone is less reliable. Even though active research is ongoing to enhance performance with this material, it is worth noting that if you point an amorphous-based thermal camera towards a fire, this can rupture the device. The following slides will show how our thermal cameras work and their benefits for various applications. Videotec thermal cameras come in two resolutions, 336 by 256 and 640 by 512, with a wide selection of lenses from 9mm to 35mm, as well as we also offer an option for advanced radiometrics. Thermal sensitivity is known as NETD, which stands for Noise Equivalent Temperature Difference. This measures the smallest temperature difference that a thermal imaging camera can detect in the presence of electronic noise. Cameras with a low NETD will detect smaller temperature differences and provide a higher resolution image with increased accuracy. Thermal camera sensitivity is measured in millikelvins, MK. They are more sensitive with values at the low end of the scale. For example, cameras with a 50 MK are 4 times as sensitive as a camera with 200 MK. The more sensitive 50 MK cameras provide a wider temperature difference, resulting in more colors on the thermal display. Let's start with the standard radiometry. These thermal cameras with a sensitivity of 50 MK would be more likely chosen for security applications, for detection, recognition, and identification at longer distances where there may be no illumination or fog or a hazy environment. With advanced radiometry, the thermal camera sensitivity is 30 MK. These are better suited for industrial applications, for monitoring high, low voltage equipment, motors and pumps, where we want to monitor high temperature or insulation loss. A thermal imaging camera is the one tool that really gets you to see it all. Temperature alarm cameras can be used for local and remote monitoring and include the possibility to set a range of temperature alarms. There are two basic types of temperature alarms. One is triggered when the temperature goes above or below the set temperature, as well as being informed when there is a rapid change. The other is a spot temperature alarm, where the camera measures the temperature of a specific area in the image. Isothermal palettes highlight the critical temperatures so they stand out from the rest of the scene. As I stated earlier, thermal imaging is the best solution when trying to see through smoke, dust, blowing sand, rain, snow, fog, and total darkness. They have a far better range than the naked eye. Although there are many factors that may influence the accuracy of radiometric surface temperature measurements, the atmospheric transmission factors can be largely negated by making measurements within 10 meters or less of the target surface in a cool and clear atmospheric settings. These conditions mitigate the impact of air temperature, relative humidity, and air particulars. For longer distances, the atmospheric conditions, camera distance, humidity, temperature, will need to be well characterized to calculate the atmospheric transmission. Measurements greater than 10 meters are further impacted by the spot size effect when the number of pixels describing any particular surface drops and the ability to make measurements over a very small objects is severely impacted. Although it is important to make measurements within a spot size diameter of less than 10 pixels, more pixels are necessary for blurred and out of focus images. For surfaces with low emissivity and high reflection, and straight-on and oblique view angles should be avoided to reduce the impact of exasperated reflection. To reduce the impact of background temperature reflection and sun glints, increasing the surface emissivity can be achieved by coupling a rough surface texture with a matte flat black paint to mitigate the impact of certain emissivity and high reflectivity. Did I say that right? Reflectivity? Off to you, Ryan.
Thanks, Frank. So there are a few guidelines when deploying the thermal cameras efficiently. So first off, the target material must be considered to avoid any mismatch between expectations and performance. Gas burning flames or targets with inconsistent temperature ranges could send out false positives. Similarly, the distances from the camera or weather conditions may seriously alter the performance. So these thresholds must therefore have proper margins. Proper calibration shall be adopted to minimize false alarms due to the transient environmental conditions. And then to increase the accuracy of temperature measurements, the regions of interest, or ROIs, for radiometric measures must span the widest possible area in the camera's view. Here we're going to show you a brief video of our customer. So the customer is utilizing a region of interest, and what he's trying to do here is send an alarm into a notification for any kind of spillage, and also they want to have any kind of preventative maintenance down the road. So the Videotec thermal has radiometric functions that allow precise temperature detection based on the image's 4 main pixels. Here we're going to show you a brief video on how to set up the region of interest on our advanced radiometric thermal cameras. However, with our advanced radiometric, we can measure the temperature of an object in any point of the image, defining up to 5 ROIs, region of interest. for a fixed camera or 5 ROIs for every preset position for a PTZ camera. The device can be configured so that it independently generates an alarm and or a warning via ONVIF events in the VMS. For example, an event can be sent when a temperature is below a set value, a temperature is above a set value, between 2 set values, or a temperature is outside 2 set values. So the Videotec thermal cameras with advanced radiometric functions also offer 3 temperature variant settings: minimum, average, and maximum. The radiometric rules can be linked to any one of these 3 thresholds. The main purpose here is protecting investments is key. So Videotec's technology is designed for security, process monitoring, life and safety. When monitoring multiple assets for substations environments such as connection points, transformers, bushings, insulators, isolators, and breakers, can alert the user to be proactive in performing some of these preventative maintenances. So the defined ROIs are scaled proportionally to the digital zoom. So when zooming in, the ROI is increased, and when zooming out, the ROI is decreased. So the PTZ's ROIs are set to preset pan and tilt positions, not zoom, so they can change in relations to the zoom. So here we're going to show a couple applications. This is a perfect example of how a thermal camera is the right solution for this. Now here is when you see the coke fall into a coke hauler, or coke from the coke drums is being taken into storage. The visibility is reduced due to the presence of the steam. So the end user wanted to optimize filling of the tanks and have a visual verification of the cart's levels. The thermal exposure-proof cameras were in place to visually verify the optimal level of each cart. And in the video, it shows the mixture of petroleum coke and water coming out of the bottom of the chute of the coke drums. And you can see that the rail car, the level of the coke in the rail car was loading. Here on this slide, you can see a couple pictures of the differentiations between the water and the coke in the rail car. Also, there's some random hot pipes in the background. So the thermal application really applies because regular cameras could not see through all the steam. Now another example is flare stack monitoring. We're using an explosion-proof thermal camera to monitor the pilot flames of a flame stock. In industrial plants, flare stacks are primarily used for burning off flammable gas and released by safety valves during unplanned overpressuring of the plant's equipment. The thermal imaging cameras are an ideal monitoring tool since they allow automated monitoring in virtually any type of weather. Although invisible to the naked eye, a thermal imaging camera can monitor whether a flame is burning or not. So now we're going to show you a brief video of how to set a warning and alarm. So here's my colleague Michael Bedard. He's our senior tech support out of our Plattsburgh office. As you can see, we configured 2 regions of interest. In box 3, Michael will lift his hand and causing a warning. So you can see the W in the box, and now he will be able to ignite a lighter. So now that he ignites the lighter, it will automatically send an alarm back to the VMS. As you can see, the box indicated a warning and the alarm. And that's how we can set up the ROIs for a flare stack monitoring.
Thank you, Ryan. Here's another example of where we can utilize thermal cameras. All coal plants have yards where they stockpile large amounts of coal, and it is of course a Class 2 environment. This client has installed our MPXT pan and tilt and our MVXT fixed explosion-proof thermal cameras to monitor any potential risks associated with spontaneous combustion or ignition of coal dust. The yard and surrounding operations, which include conveyor belts and dumping systems, can easily be supervised from anywhere in the world. The thermal camera software give the operators the ability of live monitoring, alarm management, and predetermined integration that may be introduced at a later date as the solution enhances their safety operations. Offshore drilling platforms are large structures at sea that explore, extract, store, and process petroleum and natural gas that lies at the rock formation beneath the seabed. All the equipment must be made of 316L stainless steel and comply with the explosion-proof standards. In some areas of the world, there are higher risks of sabotage from pirates that can penetrate the critical infrastructure. Our dual-core thermal and optical PTZ can integrate with radar systems to maximize a slew-to-queue capability, addressing potential risks on open water. As I stated earlier, thermal imaging cameras are an excellent tool for night vision. They have the ability to monitor in extreme conditions and do not need a source of illumination. By introducing analytics such as a cross-line detection, we can reduce nuisance alarms due to the proximity of water. Standard detectors will not work as effectively as a Doppler phenomena could occur. Videotec has collaborated on the development of a unique system which ensures early detection of hydrocarbon leaks by early detection of temperature differences between oil and seawater of the offshore platform. All this contributes to increasing the safety and security of any critical infrastructure. Lastly, Videotec has so much more to offer all industries. Here are just a few verticals that we target: pulp and paper, petrochemical, marine and rail, mining, food and beverage, water treatment plants, substations, transportation including highways, bridges, and tunnels. Any critical infrastructure application that you can think of, we have a solution. On behalf of Ryan and the Videotec family, we want to thank you for watching. If you have any questions, our specialists are standing by to support you. Warmest regards, and thank you again, and please be safe.